Welcome, guys. Welcome back to Cheenta Statistics Analytics Department, and we are live with today's problem, 5th September 2021. And it's actually a very similar problem to real analysis problem that we have done in the past. Solve a problem a day, and if you have not done the problem, stop the video and do this problem yourself, and then come back and check whether the solution is matching. If the solution is not matching, you can comment your own idea over here. Okay. How you approached it. Perfect. So let's get started, guys. And how do you do this problem? So this type of problem is done by us. This is why the idea of curve stretching is curve tracing is super important, guys. Curve tracing. What is curve tracing? The idea of curve tracing is super important, guys. So what is the idea of curve tracing, guys? Curve tracing is an application of differential calculus to understand how the curve behaves, how a function behaves, how to draw the function. So this why drawing functions are important, because it's given visual tool. So human beings are the most, like 80% of the senses, like the memory is written from the visual senses. Okay, so human beings are visual animals. So therefore, we focus on a lot of our understanding based on our visual stuff, and therefore learning these strategies really help to understand the subject in a lot more depth. So let's understand. So we'll try to draw this function, guys. Okay, fx is equal to x cubed plus x plus k. The first idea is that the number one idea, I've done exactly a similar problem for cubic function, is that it's x cubed plus x plus k. So this is a polynomial, so this is continuous. And limit x tends to infinity, this goes to plus infinity. And limit x tends to minus infinity, this goes to minus infinity. So the main question is that, like, how does this function behave? So using this three properties and from this intermediate value theorem, we can say that if a function is taking a plus infinity value, like it's taking positive value somewhere and minus infinity value somewhere, so negative value somewhere, so in between it must take at least a zero value, okay, because it's a continuous function. That's the application of intermediate value theorem. So using the intermediate value theorem to understand that there exists at least a root of the function. Now the question is that there's an essential question out here. Now the question is that if it can have it must has at least one root. So, and at most, by the fundamental theorem of algebra, polynomial can have at most three roots. So therefore, how can we determine whether it has one root or two roots or three roots? How we can determine that? So that is where the uses of differential geometry will come in. And instead of drawing, so we're trying to understand for which values of k. So instead of drawing x cubed plus x plus k, what we'll draw is that we'll draw x cubed plus x first. And that's easy. It's really easy way of doing it. So it's x into x squared plus 1. X into x squared plus 1. Sorry, that's not an easy way of doing it. I'm so sorry. That's actually not an easy way of doing it. So you will not get to understand from the roots over here. So one root is surely 0. But what are others? So in this case, what you will do is that you will take the differentiation of it. So let's consider this fx. And you take the different. You know that f of 0 is equal. So let's see all the results, all the information we have from this function. F of 0 is equal to 0. That means the function passes to 0, 0. And let's do f dash of x. F dash of x is equal to 3x squared plus 1. So it's greater than 0. That means what? Understand it very carefully. That means what? It's an increasing function. It's an increasing function. So how does that help? If it's an increasing function, how does that help? It's super easy. If it's an increasing function, f dash is x is greater than 0. If it's an increasing function, that means what? That means we know that at 0 there is a value 0, that the function is passing to exactly 0. Okay, it's an increasing function. That means what? That means the function is always an increasing function. How increasing? I have not drawn the graph of it. The function is always an increasing function. The question is that can it have more than one roots? Can it have more than one roots? Yes, it can have more than one roots. No, it cannot have more than one roots. Don't guess it wrong. If it has more than one roots, then what will happen? Let's say it has a root here. So therefore, if it has root, 0 may root here, and let's say there is another root, that means by Rolle's theorem, f of 0 is equal to 0, and let's say f of a is equal to 0. By Rolle's theorem, there exists a point between a and 0, so that f dash of that xi is equal to 0. But we know that f dash of x is always greater than 0. So it is not possible. So it must exactly has one root. And if you just put a k over here, doesn't matter. Maybe the root will change. Okay, but we know that it must have a somewhere in a root in between by this idea of IVT. Okay, so it doesn't matter. So it's just when you just add k, it's a shift like this above. Just add k like this. It's just shift above. Shifts above or below depending on the sign of k. So the root remains same. The behavior of the function remains same, but the roots change. The roots number of roots remain same. The behavior of function remains same. Only its location shift is just shifted towards the up or down. So therefore, it must exactly has one root. And also, since it's a continuous function and it's increasing, it must have exactly one root. Why? Because it takes values below the x-axis and below the x-axis and above the x-axis. So since it's continuous by interval value theorem, it must take a value in between, and that's why it take a 0 value. Can exactly 1 because it's increasing. So this idea of curve tracing and understanding a function via its differential calculus is something we really stress upon in Cheenta. Okay, and I think it's super important. And in fact, that it was one of the most essential skill in the JEE in the 11-12. And why it was an essential skill in the exam? Because it's an essential skill in understanding the theory and understanding the function in general. That's why it's an essential skill in the exam also. So perfect. So I hope you enjoyed the problem, guys. And yeah, so I will do stay tuned and do stay tuned with the problems that are coming next tomorrow and previous days problems. And yeah, so see you next day and stay tuned and stay blessed. By the way, if you're looking for some crash courses to help your build and problem-driven crash courses for enhancing your performance in IIT JAM MS 2022. So do check the link below in the description about our crash courses. And yep, so all the best, guys. And if you like them, do let us know. And if you have any queries, do let us know in our WhatsApp support team. All the best, guys, and I will see you in the next video explaining some different interesting problem. And if you did like the problem, if you did like us, if you do support our regular problem solving, do like and share and subscribe and share to the other friends about the together problem solving we are doing to enhance your skills and our teaching skills. So happy Teachers Day to all the teachers out here and all the students out here. Happy Students Day to all of you, because I mean, after all, without the students, the teachers don't exist. So it's an ecosystem. It's a beautiful relationship in a family. So thank you, guys, and I will see you in the next video. Stay tuned and stay blessed. Bye-bye.